This is R.D. Sharma Solution Class 12, Chapter 5. Exercise is 5.4, Algebra of Matrices. Now, this exercise is totally based on the transpose. Transpose is nothing but conversion of all rows to the corresponding columns. So, please just watch this question very carefully because there are multiple questions being repeated. Just like that. Okay. So let us start with this one. First one, A is 2, -7, -3 and 5. So we have to multiply it by 2 because it is twice of A being given in the question. So what do we get when we multiply 2? 2 to the 4, -6, 7 to the 14, -14 and 5 to the 10. Now take the transpose, rows to column. So make the row as column or column as rows. Same thing, okay? So 4 minus 6 is our row, we'll make it as a column. So 4 will come here, -6 will come down. Similarly, this -14 and 10 has to be converted into, this is row, so we have to convert it into column. Okay. So this is A. So A transpose, let us see the transpose. So 2 and -3, this will be the first column, -7 and 5 will be the second column. Now take the twice of this of A transpose. So 4 minus 14 and 2, 3 minus 6 and 5 to the 10. So what do you get? Did you get these two equal? Yes, they are equal. So hence proved. So others also will do the same thing. As I said, the second, third are almost equal and the fourth part is repeated in the later question again and again. So we'll do it properly. Okay, this one. Second and third are exactly similar, so we will do either second or third. Third one I'm taking. Once you have to take the addition, once you have to take the subtraction. So A minus B I'm taking, third one I'm taking, A minus B. So 2 minus 1, I'm directly doing it. 2 minus 1 is 1, -3 into 0 is -3. -7 minus 2 is -9. 5 minus 1 minus 4 is 9. Now I'll take the transpose of this. Row to column. So 1, -3, this -9 and 9. Okay. Now A transpose and B transpose. So A transpose we have already seen. We have already done A transpose. So let me just write this 2, -7, -3 and 5. What about the B transpose? This is A transpose. Let us do the B transpose and put it here. B transpose is, this is 1, 0, this is 2 and -4, 2 minus 4 here. Okay, what do you get? 2 minus 1 is 1, -7 minus 2 is -9, -3, 0 is -3, 5 minus 4 is 9. Now do you see these two are equal? Yes, absolutely, they are same. So second and third are almost similar. Now coming to the fourth one, as I'm saying, these are just repeated. In the next questions, these are repeated. So just see it very carefully. So we'll do A and B multiplication and then take the transpose. Then we'll do B transpose and A transpose and then we'll multiply them. So A, this is A, 2, -3, -7 and 5. And B, this is B. So 1, 0, 2 and -4. And now multiply. So first row with first column, 2 into 1 is 2 and -6 because -3 into 2 is -6. Now 2 into 0 is 0, -3 into -4 is +12. So we get 0, this is -3, okay. So 2 into 0, 0 plus 12 it is because -3 and -4 is 12. Right. Now -7 into, now the second row with the first column. -7 into 1 is -7, 5 2s are 10, so -7 plus 10 it will be. Now -7 into 0 and 5 into 4, -20. So what do you get? -4, 2 minus 6 is -4, this is 12, 10 minus 7 is 3 and -20, right? So this is A into B. Now we'll take the transpose of this, row to column. So this will be -4 and this comes down, 12. Then we have this 3 and -20. Okay. Then we'll take the B transpose and A transpose. So B transpose and A transpose will multiply. I'm directly doing it. B transpose. Let me change the color. This is A and B. So B transpose. 1, 0, 2 and minus 4. Row to column. Then we have A transpose. So A transpose we have already done in the earlier part. So this is 2 minus 3 in the column and minus 7 into 5. Now let us multiply it. So 1 into 2 is 2. 1 into 2 is 2 and 2 into minus 3 is minus 6. 1 into minus 7 is minus 7. And 5 into 10 is 10 plus 10. Now 0 into 2 is 0. Minus 4 and minus 3 is minus 12. 0 minus 7 is 0. Minus 4 into 5 is minus 20. So what do you get? Minus 4. 10 minus 7 is 3. Minus 12. And this is minus 20. So what do you see? This one and this one, they are same. That's what we wanted. Right? Now A is this, B is this, AB transpose and B transpose, A transpose. We have just done a question like this. As I said, these all parts are repeated. That's why I did the first part. And see, A into B is possible or not. This is 1. This is 3 rows and 1 column. This is 1 row, 3 columns. So the multiplication is possible. And B transpose will take, because you know, A is a column matrix, B is the row matrix. So A is this. A, when we transpose, it will be a row matrix. B, this is a matrix, so the transpose will be column matrix. Then we multiply A and B. Then we take the transpose. Then we multiply B transpose with A transpose. So we already done the transpose. When we multiply, we just have to verify that AB transpose is equal to B transpose into A transpose, and that will come equal, these two. Okay. So this already done. Now you see all these questions we have already done. These already done. Just the difference is previously we have done 2 by 2 matrix. This is 3 by 3 matrix. The method remains the same. Okay. So let me show you. The first one we'll take. I'm taking whichever is possible. So I'm directly adding. First part I'm doing A and B. I'm directly adding A plus B. What is A plus B? 1 plus 1 is 2. Negative 1, 2 is 1. 1. 0 and 3 is 3. 2 and 2 is 4. 1 and 1 is 2. 3 and 3 is 6. 1 and 0 is 1. 2 and 1 is 3. 1 and 1 is 2. This is A plus B. Okay. Now we need to do the A plus B transpose. Let us do the transpose rows to column. 2, 1, 3 will become a column. 4, 2, 6. 4, 2, 6 is a row, so it will become a column. And 1, 3, 2, it will become a column. So A plus B transpose. Now we'll do the A transpose and B transpose and we'll add it. So I'm doing it directly, okay. So this 1, negative 1, 0 will be the column. 2, 1, 3, which is a row, will become a column. 2, 1, 3. 1, 2, 1 will again become a column. Then we add with B transpose. This is A transpose. This is your B transpose. 1, 2, 3 will become a column. 2, 1, 3 will become a column. 2, 1, 3. And then 0, 1, 1 will also become a column. Now let us just add it. So 1 plus 1 is 2. 2 plus 2 is 4. 1 plus 0 is 1. Negative 1 and 2 will give you 1. 1 and 1 will give you 2. 2 and 1 will give you 3. 3 and 3 is 6. 1 and 1 is 2. So this is A transpose plus B transpose. Now let's just verify. Are these two equal? Yes, they are. They are equal. So this I told you. Now A into B. So we have taken the transpose, so we are going to reutilize it. So A B transpose equals B transpose A transpose. Let us see here. Okay. So when you multiply A and B, you have to do the transpose. Then we'll take the B transpose and A transpose that we have already seen just now, and then we'll multiply them. So when you multiply, this AB transpose and B transpose A transpose is going to come same. Now 2 into A transpose equals to A transpose. What you have to do, first you take the matrix, multiply it by 2, then you take the transpose, row to column. Now this A transpose, which we have already done, just multiply it with 2. And if you see, they are going to come same. So I'm just saying that when you multiply A transpose with 2, A transpose we have already done, so I'm just multiplying it with 2, 2, 4, 2, and negative 2, 2, 4, 0, 6, 2. So they are going to be same. 2A transpose, this is equal to 2A transpose. A and B, this is, as I said, this was the third part in the first question. The second question is absolutely like this. So this is just a repetition. I hope you'll be able to do it. You just have to take A, find out the A transpose, B, find out the transpose, because they are row matrix and column matrix. Multiply these two and then take the transpose, rows to column. Just change it. Now B transpose and A transpose, just multiply this and you will get these two exactly similar. If A is this, B is this, A into B and then transpose. So we'll learn two things, A into B and also the transpose of this. So let us see one by one. I'm going to do it properly. So we'll multiply these two matrix and then take the transpose. Transpose is simply rows to column. This is 2, 4, negative 1, negative 1, 0, 1, negative 1, 0, 2. Then we have 3, 4, negative 1, 2, and 2, 1. Okay. So first row with first column, 2 into 3 is 6, 4 into minus 1 is minus 4, 2 into minus 1 is minus 2. So now first row with the second column, 2 into 4 is 8, 4 2s are 8, minus 1 into 1 is negative 1. Now second row with the first column, negative 1 into 3, 0, leave it, 2 into 2, 4. Now second row with the second column, minus 1 into 4, minus 4, 0, leave it, 2 into 1 is 2. Now this is a value. So what do you get? Let me just write this value. This is 0, 8, 8, 16, 15. 4 minus 3 is 1, minus 4 into 2 is minus 2. Now this is A into B. This is just a multiplication we have done. Transpose is row to column. This 0, 15 will become a column. 1 negative 2 is a row, it will become a column. So this is A into B transpose. Okay. Next one is for two matrices A and B, we have to verify that AB transpose is equal to B transpose A transpose. So these type of question we have already seen, but we'll do one of it. So let us take the first one, because second one is you can do it because it is just 2 by 2 matrix. So let us see the we'll multiply A and B and then take the transpose. So let us multiply first. And then we'll do the B transpose into A transpose. So I'm writing A here. This is 2, 1, 3, 4, 1, 0. And then we have this B. 1, negative 1, 0, 2, 5, 0. Okay. First row, first column. 2 into 1, 2. 1 into 0, leave it. 3 into 5, 15. Add this. Then first row, second column. 2 into minus 1, negative 2. 1 into 2, 2. 3 into 0, leave it. Second row, first column. 4 into 1, 4. 1 into 0, 0. 0 into 5, 0. Now second row, second column. 4 into negative 1, minus 4. 1 into 2, 2. 0 into 0, leave it. So what do you get? We have 17, 0, 4 and negative 2. Now this is A into B. This is just A and B. You have to take the transpose of it now. So the row will become column. 17 and 0, this row will become column. This 17, 0, this is going to be 4, negative 2. Right? Okay, this is the first part. We haven't done the B transpose and A transpose. So we'll take the B transpose, take the A transpose and then multiply. So B transpose, first we have to do the B transpose. Row will become column. So 1, negative 1, 0, 2, 5 and 0. Now A transpose. This is B transpose. We have already done. Now A transpose. Row will become column for A. So this is 213, 213. 410 will become a column. 410. Okay. So now row with column. 1. Let me change the color. 1 into 2, 2. 0 into 1, leave it. 5 into 3, 15. Now first row, second column. 1 into 4, 4. 0 into 1, leave it. 5 into 0, leave it. Minus 1 into 2, minus 2. 2 into 1, 2. 0 into 3, 0, leave it. Minus 1 into 4, minus 4. 2 into 1, 2. 0 into 0, 0, leave it. So what it is? I am multiplying B transpose with A transpose. So what this was what? This was AB transpose. So this becomes 17, 4, 2 minus 2 is 0, 4, 2 minus 4 is minus 2. Are they same? Yes, they are same. If Li, Mi, Ni, I equals 1, 2, 3 denotes the direction cosines of three mutually perpendicular vector in space. So when we have the mutually perpendicular vector direction cosine, what are the relationship? See, just let me just take this L1, M1, N1, and the direction cosines are given, and always when we have 90 degree between cos 90 degree is 0. Okay, please remember that. So we have certain relationship between this L, M, N. If we have the three vectors L1, M1, and N1, L2, M2, N2, and L3, M3, N3, depicting or indicating certain direction cosine. So let me just show you. The first one will be L1 square plus M1 square plus N1 square will be equal to 1. L1 square plus M1 square plus N1 square will be 1. Similarly for 2, for 3. That is L3 square, M3 square, N3 square. L2 square, M2 square, N2 square will be 1. Second thing is, when we have the, when we take the clockwise or anti-clockwise, L1, L2, M1, M2, N1, N2, or say L2, L3, M2, M3, N2, N3, or L3, L1, M3, M1, and N3, N1, they are going to be 0. So these two things are very important in solving this kind of question. Now let us multiply. So A I am writing, and then we'll write the A transpose. What is A? A is already given to us. So this is L1, L2, L3, M1, M2, M3, N1, N2, N3. So this is A. Now we'll take the transpose. So the row will be column. This is A, this is A transpose. This is L1, M1, N1. Then we have L2, M2, N2. L2, M2, and N2. Then we have the row change to column L3, M3, N3. Now we have to take the multiplication and we'll then apply the properties. The first row, first column, L1 square, M1 square, N1 square, just add them. Now first row with second column, L1, L2, plus M1, M2, plus N1, N2. Okay. Now first row with third column, L1, L3, M1, M3, then N1, N3, plus N1, N3. This is the first one, and the others also will be similar to like this. So L2, L1, second row, first column, M2, M1, plus N2, N1. Now second row with second column, L2 square, M2 square, and N2 square. Now second row with third column, L2, L3, plus M2, M3, plus N2, N3. Now coming to the third row with the first column, L1, L3, plus M1, M3, plus N1, N3. N3, N1, or N1, N3. Now third row with second column, L3 L2 plus M3 M2 plus N3 N2. The third row with the third column, L3 square plus N3 square plus N3 square. Okay. What you have to do? We have already discussed about the properties. This one will be 1. But all the column, or you can say the diagonal, will be 1. This is 1, this is 1, this is 1, as per the properties. From where it has come? From here. And what about others? They are all are zeros. You just verify this. All these are zeros. Just let me put zeros. So because these are the direction cosines of 3 mutually perpendicular vectors. This is A transpose. When we multiplied, we got I3, identity matrix. Okay. This A is given. We have to verify that A transpose into A equals the identity matrix. Let me show you the other question also. The 9th question, which is exactly similar to this one. I don't know why the repetition is there in the R.D. Sharma book, but still, let us take one of these. Let us take this one only. Okay. So multiply these two because we have to take the A transpose. So let me write the actual matrix first. A I am writing first. Cos alpha, sin alpha, minus sin alpha, and cos alpha. Now I am taking the A transpose. I am making this as a column. Cos alpha will be here and sin alpha will be below that. Then this row will be column minus sin alpha and cos alpha. Okay. Now let us multiply. This is A transpose, this is A. It has to come as identity matrix. Cos, first row, first column. Cos alpha into cos alpha, cos square alpha. Minus minus is plus, so plus sin square alpha. First row, second column. Cos alpha into sin alpha. And minus sin alpha into cos alpha. The second row with the first column, sin alpha into cos alpha. Minus sin alpha, cos alpha. The second row with the second column, sin alpha, sin square alpha plus cos square alpha. Now sin square theta plus cos square theta is 1, so these two are 1, and they get cancelled because they are similar terms. So what do you get? 1, 1, 0, 0. This is nothing but identity matrix. Let us write it as 2 because this is 2 rows, two columns. This also you can do. Okay, there is a solution. Next question is CBSE 2012 question. So A transpose is already given. Let us take 3, 4, minus 1, 2, 0, 1. This is already given. A transpose. Now let us take the transpose of B. So row will become column. Minus 1, 2, 1. This will become as 1, 2, 3. And then subtract it. 3 minus of minus 1 is 4. 4 minus 1 is 3. Minus of 1 of minus 2 minus 3. 2 minus 2 0. 0 minus 1 is negative 1. 1 minus 3 is negative 2. So this is your final answer. Okay. Okay, this is all about this exercise. Thank you so much. Take care of yourself.